Good day, everyone. For this part, I will be discussing the introduction to the principle of lightning protection. So, lightning is a very powerful natural phenomenon capable of producing currents up to 200 kiloamperes and voltages reaching around 300 kilovolts. Because of this extreme energy, lightning can cause serious damage to electrical equipment, structures, and even pose risk to human safety. That is why lightning protection is very important in any electrical or structural system. To understand how protection works, we first need to look at how lightning forms. According to studies, lightning occurs due to buildup of opposite electrical charges between the cloud and the earth. The cloud typically becomes negatively charged, while the ground becomes positively charged. This difference in charge creates that what we call potential gradient in the air. As this gradient increases, it reaches a critical point where the air can no longer act as an insulator. When that happens, electrical breakdown occurs. At this stage, a conductive path called a streamer forms, allowing the electrical discharge to travel from the cloud to the ground. This is what we see as lightning strike. Understanding this process is important because lightning protection systems are designed to safely control and redirect the discharge, preventing damage to structures and equipment. Now that we understand how lightning forms, let's look at how it interacts with structures. So there are four main mechanisms of lightning interaction classified as S1 to S4. So first, S1 flashes to the structure. This refers to a direct lightning strike to the building itself. This is the most dangerous case because the full lightning current flows through the structure, which can cause severe physical damage, fire, or equipment failure. Next, S2 flashes near the structure. In this case, lightning does not hit the building directly but strikes nearby, such as the ground or surrounding objects. Even without direct contact, it can still induce high voltages in the structure due to electromagnetic effect. Third, S3 flashes to the surface connected to the structure. This happens when lightning strikes utility lines connected to the building, like power lines, telephone lines, or internet cables. The surge can travel along these lines and enter the structure, potentially damaging the internal equipment. Lastly, S4 flashes near a service connected to the structure. Here, lightning strikes near a service line but not directly on it. Similar to S2, this can still induce surges that propagate into the building through connected system. Understanding these four mechanisms is important because lightning protection systems are designed to address each of these scenarios to minimize damage and ensure safety. So, now that we've discussed how lightning interacts with structures, let's look at its effect on structures and systems. So there are three main types of damage caused by lightning. First, D1, injury to living beings due to touch or step voltages. This occurs when lightning current flows through the ground or conductive materials, creating voltage differences. When a person or animal comes into contact with these areas, it can result in severe electric shock, injury, or even death. Second, D2, physical damage to structures. Lightning can cause direct damage to the buildings, such as cracks, fires, or structural destruction. This is mainly due to high current and extreme heat generated during a lightning strike. Lastly, D3, failure of internal systems due to lightning electromagnetic pulse or LEMP. Even if the structure itself is not heavily damaged, the electromagnetic effect of lightning can disrupt or destroy internal electrical and electronic systems, such as computers, communication devices, and control systems. These effects highlights why lightning protection is not only about protecting the structure itself, but also about ensuring the safety of people and reliability of internal system. Now, for this part of presentation, I will be discussing the consequences of lightning damages, which is an important concept in the principle of lightning protection. So, lightning can cause different types of damage, either individually or combined, depending on the situation. According to international standards, particularly IEC 62305, a type of damage or loss depends on the characteristics of the structure or object being protected. There are four main types of losses caused by lightning. So first one, L1, loss of human life. This is the most serious consequence. Lightning strikes can cause severe injury or death, especially if proper protection systems are not in place. Second, L2, the loss of service to the public. This refers to interruptions in essential services such as electricity, communication system, hospitals, or transportation, which can greatly affect communities. Third, L3, loss of cultural heritage. Lightning can damage historical buildings, monuments, and artifacts that are valuable and often irreplaceable. And lastly, L4, loss of economic value. This includes damage to structures, equipment, and business operation, which can result in costly repairs and loss of income or productivity. Overall, these consequences highlight why lightning protection systems are very important. They are designed not just to protect buildings but also to save lives, preserve services, and reduce economic and cultural losses.
Lightning protection systems are used to protect buildings and structures from damage caused by lightning strikes. These systems work by capturing lightning and safely directing the electrical current to the ground. The common types include the lightning rod with taut wires, and the mesh cage or Faraday cage system. First is the lightning rod or simple rod with triggering system. The lightning rod is a metallic capture tip placed at the top of a building. It is connected to the ground by one or more conductors, usually made of copper strips. As shown in the picture, if lightning hits the metal rod on top of the building, the electricity will travel through the copper strip or down conductor on the wall and then go into the earth through the grounding system at the bottom. This protects the building and the appliances inside. Second, lightning rod with taut wires. In this type, wires are stretched above the structure to be protected. These wires intercept lightning before it reaches the structure below. This system is commonly used to protect special structures such as rocket launching areas, military facilities, and high voltage overhead lines. In the picture, you can see a wire stretched between two metal posts above the house. If lightning strikes, it will likely hit this top wire instead of the roof of the house. The electricity then travels down the metal post to the grounded earth belt, protecting the house underneath. Lastly, lightning conductor with mesh cage, or also known as the Faraday cage. This protection system involves placing numerous conductors or tapes symmetrically around the building, forming a mesh or cage-like structure. It is commonly used for highly exposed buildings that contains very sensitive installations such as computer rooms or data centers. As shown in the picture, if the lightning strikes the top or side of the building, the electricity will flow through the green mesh conductors surrounding the structure and go down to the grounding points at the bottom corners. This protects the entire building, especially the sensitive equipment inside. In conclusion, these lightning protection systems help protect buildings by providing a safe path for lightning current to flow into the ground. By doing this, they reduce the risk of structural damage and protect the people and equipment inside the building.
Consequences of building protection for the electrical installation equipment. This from a blog published by Electrical Installation Weekly. 50% of lighting currents discharged by the building protection system rises back into the earthing networks. The electrical installation. The potential rise the frame and frequently exceeds the insulation. Withstands capability of the conductors in the various networks, LB, telecommunication, video call, cable, etc. Moreover, the flow of current through the conductors generates induced overvoltage in the electrical installation. As a consequence, the building protection system does not the electrical installation. It is therefore compulsory to provide for an electrical installation protection system. Lightning protection, electrical installation protection system. The main objective of electrical installation protection system is to limit overvoltage to values that are acceptable for the equipment. The electrical installation protection system consists of one or more PDS depending on the building configuration. The equipotential bonding metallic mesh of exposed conductive parts. Here are the assessment steps. Identify all sensitive electrical and electronics loads under NT points. Check for existing lightning protection system in the building underground. Review local regulation and lightning risk factors, location power, supply strike density.
The Source Protection Device or SPD. Source Protection Device used for electrical power supply networks. telephones, networks, and communication, and automatic control box. Electrical installation of Wiki 2023, the surge of protection device is component of the electrical installation protection system. This device is connected in a parallel on the power supply circuits of the loads that it has to protect. It can also be used of the all levels of the power supply of networks. This is the most commonly used for the most efficient type of the voltage protection. So makita ninyo dire no ata diagram na the incoming circuit breaker and the light current and then sensitive loads. So sample of this no kusog na kuryente nga mo-observe or mo-direct. So ang resulta niya is maluwas imong mga gamit like a TV, computer, or whatever else. The three types of SPD. So type 1 is protect electrical installation against the direct lightning stroke. It has a character by 10 to 350 current waves. So ang type 2 is it prevents to spread the over voltage the electrical installation and protect the loads. It has the character by an 8 over to 20 current waves. So ang type 3, they have a low discharge capacity. It has the characters by the combination of the voltage waves of 1.2 to over 50. And the current niya is 8 to 20. And then sa type 1 is mo handle siya pinakakusog nga surge. And then ang type 2 is mo control siya nga sa atong nahabilin nga surge. And then ang type 3 is protect sa imong mga gadgets.
Now, I will discuss the protection measures. So this slide shows different protection measures against lightning for electrical systems, people, structures, and services. So for electrical system, so we install bonding conductors and surge protection devices. So this help control sudden high voltage and protect equipment. So for example, so when lightning strike near a building, the surge protector prevents computers and appliances from getting damaged. So the diagram of this slide shows how electrical systems are protected from lightning using grounding and surge protection devices or SPD. So electrical power comes from the medium voltage supply and enters the building. At the main switchboard, an SPD is installed to protect the entire system from sudden voltage spikes. So the building is also connected to the ground using bonding conductors, which safely direct excess electrical energy into the earth. So for better protections, additional SPD are placed in self-distribution ports, especially near sensitive equipment like computers. So overall, the idea is to stop lightning surges at different points and safely guide the energy to the ground to prevent damage.
So next slide for people. So exposed metal parts should be covered and properly grounded. So this prevents electric shock. So for example, if a metal railing is struck by lightning, grounding ensures the electricity goes safely to the ground instead of passing through a person. So next is for structures. So lightning protection systems like rods and grounding are used along with fire safety measures. So for example, a lightning rod on top of a building directs lightning safely into the ground, preventing fire or structural damage. So next is for services. So cable are shielded or placed in metal ducts to reduce lightning effects. So for example, underground cables inside metal pipes are less likely to be damaged during a lightning strike. So next, conclusion. So lightning can be very dangerous to people, buildings, and electrical systems. Knowing where lightning can strike, the kinds of damage it can cause, and the possible losses help us protect against it. So using lightning protection system like rods, wires, cages, and surge protectors, along with safety measures such as grounding, bonding, and insulations, can greatly reduce the risk of injury and damage. So proper protection keeps people safe and helps buildings and equipment stay working even during storms. This is the last part of our slide. This is our references. So these are the references we use for our report. So that's all for today. Thank you.